Yeah, let's start discussing about the air conditioning and ventilation system design calculation. Okay, so as you said, you have completed the architectural package, correct? So next part, when you go to the technical side, okay, technical part. So if you go to my folder structure, you can able to see that there is architectural space planning, and the next one, introduction about air conditioning and ventilation. Okay, so if you go inside air conditioning and ventilation, there is ASHRAE climate design conditions, right? So this is one of the very important document to understand what is the ambient conditions. Say for example, if you go to ASHRAE climatic design condition, okay, like 2021, okay, so you should understand that what is the annual design condition, the annual heating and humidification, annual cooling, dehumidification and enthalpy design conditions, extreme annual design condition, monthly design conditions like temperature, degree days and degree hours, wind, precipitation, monthly design, wet bulb, dry bulb, and mean coincident temperatures, mean daily temperature ranges. So this is the guideline you should understand. Okay. So
Yes.
let me open one of the website. Uh, yeah. See, if you go to one of the website, you can able to enter ASHRAE climatic conditions, right?
Okay.
Okay. So if you go inside, you can see that ASHRAE climatic design condition. Okay. Say for example, I'm in Asia. Okay, for example, and I will go to uh, United Arab Emirates. Then assume that I'm
Okay.
going to Abu Dhabi International. Okay. So here,
Okay.
can you, if you see that ASHRAE guideline, ASHRAE handbook, what they are saying that what is the weather properties, right? So you are a
Hmm.
HVAC engineer, you should understand that what is the outside condition. Then only you can bring it to the design condition, right? Say for example, you are in the bedroom, for example. Okay, what is our human comfortable? What is the design condition?
24, 25 degrees Celsius.
Yeah, 24 degrees Celsius and 50% RH. That is a human
Yes.
comfort, correct?
Yes. Yes.
Okay, now you should know what is outside condition. Then only you can bring it to the design condition, right? Assume that your outside condition is 2 degree dry bulb temperature and say for example minus 1 wet bulb temperature. So what you will do?
Heating.
Yeah, heating, right? And
Yeah.
assume that
Yes.
your outside temperature is like 46-degree and 29-degree wet bulb temperature, then you are going to apply sensible cooling, right?
Yes.
So that is why you should understand that the ASHRAE fundamentals, okay, like what is the annual condition for each and every climate. You can able to go, you can able to access the global countries. Say for example, Asia, North America, Latin America, Australia, Europe, Africa, Antarctica. All the global you can able to access here, right?
Okay.
So
Okay.
if you go to the next one, uh, assume that this is your design condition for Abu Dhabi. Okay, so you can see here what is the extreme condition. Normally, when we design the air conditioning, we go to the extreme design condition 47.6 and 31.6 degrees Celsius, right? This is the extreme
Yes.
maximum design condition. So, that understanding we should gain that
Yes.
knowledge. Okay, and what is the
Okay.
coldest month? It is a January month. One means January month. So that type of
Yes.
to study to get the knowledge, you have to go through this particular ASHRAE guideline. So what is that coldest month? What is the hottest month? Right, and what is the dew point temperature? What is the extreme annual design conditions? So you have to go through all this document to understand this ASHRAE guide, ASHRAE fundamentals. Clear?
Yeah.
Okay, so take your time, go through all this, whatever the document I have shared, and understand that ASHRAE fundamentals. Then we will move further. Okay, and
Yes.
also if you go to the carrier psychometric, okay, I have shared one design guideline for the design chart from ASHRAE guide from carrier, right?
Yes.
So here also you can able to understand. Take your time to read what is psychometrics, okay, and to understand what is the properties of air and vapor. Okay, what is that dry air? See, so sometimes you heard about some people say that the air is very dry outside, right? And
Yes.
sometimes you heard that the outside is very moisture, the climatic condition. Okay, so you are going to understand what is dry air, what is water vapor, and what is the when you have a mixture air plus vapor, what is that condition?
Okay.
Okay, and if you go to that, what is the humidity and its source? From the humidity, where it comes from? That basic understanding, right?
Yeah.
And how the air vapor mixture reacts. When the air vapor mixture, how it will react. and the temperature and pressure.
Okay.
Okay, so this type of understanding I want you to read, because this is the basic. When you are a HVAC engineer, you should put a proper foundation. Okay, like the understanding of psychometric chart. Okay, see further, if you go further, okay, you have a transformer ventilation calculation. As an example, what is a transformer ventilation? It is a what is a type of load? Is it a sensible or latent? Can you explain?
It's a sense like heating. Transformer will heat. Will have a heating, so we have to cool. Sensible cooling.
No, no. What I'm saying, the transformer
Oh,
ventilation. Okay,
okay.
transformer is a equipment, right?
Yes.
Is it a sensible type of equipment or latent type of equipment? What type of heat it will dissipate? Sensible heat or latent heat?
It's will a sensible heat.
Yeah, it's because it's a equipment, right?
Yes.
So what is sensible heat? Sensible is a dry, right?
Yes.
And when you talk about latent, it is a moisture, correct?
Yes. Yes.
So moisture comes from which type of equipment? You have any idea?
Yes. Like moisture will be coming from like steam. Any steam and like which
Yeah,
produces
yes,
steam.
steam, or sometimes you can say the kitchen equipments, right?
Yes. Yes.
So the kitchen equipment will have a sensible and latent. But say for example,
Yes.
you have a generator, you have a battery, you have a transformer. This is only a sensible equipment, right? So
Yes.
when you have a heat dissipation from the transformer, what type of cooling you will do? Sensible cooling or latent cooling?
Sensible cooling.
Sensible cooling, right? So you are going to do the
Yes.
sensible cooling. So sensible
Yes.
cooling, how you do that is provided in the psychometric chart. So that understanding is required. Okay. If you
Okay.
go further
Okay.
down, okay, say for example, you have here you can see there is a dry bulb temperature and the specific humidity and dew point and the saturation line, relative humidity lines. Try to understand the psychometric, okay, wet bulb temperature lines. Okay, then go to specific volume line, enthalpy. What is enthalpy? How to calculate enthalpy, right? And you can see that
Yes.
psychometric chart. There are different conditions like a dry bulb temperature, wet bulb temperature, dew point temperature, specific humidity, relative humidity, specific volume, right?
Yes.
And using the psychometric chart, there are two type of psychometric. One is the sea level, and another one is high elevation. Okay,
Yes.
okay. Then
Yes.
after that, there is a mixing and coil leaving air. Eight basic process types: sensible heating,
Yes.
sensible cooling, humidification, dehumidification, cooling and dehumidification, heating and
Yes.
dehumidification, right?
Yes. Yes.
And you can see here, just now we discussed the sensible and latent heat changes, right?
Yes.
So when you are going to do the sensible heat, what is the formula you will apply to calculate your capacity? Sensible load. How to calculate the sensible load?
Okay.
Okay. And how to
Yeah.
calculate the latent load? What is the formula? That is also given in the psychometric chart. So if you have this basic idea, then you can do any type of calculation. If you go to further down, you can do the heater calculation. What is a heater? Is it a sensible or latent?
We like room heater, right?
Yeah, room heater. Is it a sensible or latent?
It's a sensible.
Sensible, right? Because it's a
Yes.
heating, and
Yes.
humidifier is a sensible or latent?
Yes. Humidifier is like humidifier is latent.
Latent, because it's a moisture, right? It's producing steam.
Yes.
Okay, so
Yes.
that type of understanding you will get it from the psychometric chart. So how to calculate sensible load, how to calculate latent load, how to calculate the total load, right?
Yes.
So when you see this particular picture, can you see here? There is a heating and there is a evaporation. When you do the heating, there
Yes.
is a evaporation. That is called latent, right? Because latent is what? It is
Yes.
a change in state, right?
Yes. Yes. Liquid to
Okay.
vapor.
Yeah. So when you calculate the total, you're going to calculate the delta T and the temperature and also the delta grains. Grain is nothing but
Yes.
the moisture content. So when you calculate
Yes.
both, you can able to calculate the total heat.
Yes.
Okay. So that type of understanding, right? And you can
Yes.
calculate the heat removed. How much heat is removed from this temperature to this temperature from the sensible. This is the sensible load. This is the latent load.
Yes. Okay.
Right? Okay, so
Yeah.
that type of understanding you will get it from the psychometric chart. So I request you to go through the psychometric chart. Take 1 week, 2 week, no problem, because this is the foundation, right?
Yes.
Okay, go through all the pages. If you want to go through all the pages, you can go through. There are 71
Yeah.
pages. Take your time to read all the 71 pages, because this is the
Oh.
basic. Okay, I'm not asking you to read the other document. Like for example, if you go to if you go to introduction about air conditioning, you don't need to read all these documents. Okay, just to open the document, just to have a glance. Okay,
Okay.
but this particular psychometric chart, I want you to go through in detail. Okay, try to
Okay.
understand
Okay.
each and every line. Just to have a one read. I don't. I'm not asking you to remember. Okay,
Okay.
and even if you don't understand, also no problem. Just read one time so that maybe now maybe in the 2025 maybe you will not understand, but maybe after some time when you become a senior and when you work with a different project, you can able to connect to each other, right?
Yes. Yes.
Okay, so that foundation you can start now itself. Can I know how many years you have experience?
5 years.
5 years, right? So, but when you
Yeah.
become like, say, for example, when you become 20 years experience, that time you have a very good knowledge.
Yes. Okay.
Okay, so your foundation should be starting from now, but looking forward, like when you become a senior engineer, when you become a principal engineer or project manager, okay, that time you should have a very good skill so that you can able to defend other people. When you have a, say, for example, you are in a contractor or you are working in a consultant, okay, when you go and speak to someone else, okay, if you have a technical knowledge, you can able to speak very confident, right?
Yes.
Okay, so maybe you will learn for some time for technical, but that technical will help you to manage. It will help you to work as a project manager. It will work. It will help you to work as a in a high level management skills, right?
Yes.
Okay, so you start from foundation. There is no problem. Take your time. Read the psychometric chart. Then we will move next one by one calculation. Okay, Tom.
Okay. Yes.
Okay, and also I request you to study. Okay, if you go to a half thermal load calculation, okay, go to the
Yes.
design guideline and try to understand. This is the cooling load calculations.
Okay.
Okay, so in the cooling load calculation, if you go to one of the picture, okay, can you see this type of picture here? So there are external load and internal load, right?
Yes.
Okay, so when you say there are heat there are heats inside the building. Okay, so the heat come from where? Say for example, you have a heat coming from light. Okay, and the heat coming from the window, coming from the walls, floor, people. So these are the heats, right? Say for example, you are a
Mm.
mechanical engineer. You are going to do the air conditioning for the particular rooms. Okay,
Yes.
so in the particular room, you are going to calculate what is the cooling load required, right? Or what is the heat
Yeah.
inside, heat load. Okay, how much
Yeah.
cooling load required and what is the heat inside. So based on the heat inside, you can able to calculate what is the cooling required, correct?
Yeah.
So you are going to find out what are the heats. The heat is coming from light, ventilation, appliances, floor, people, walls, window, solar, ceiling and roofs. Okay, so there are external heat, there are internal heat, right?
Yes.
Okay, so that each heat, how to calculate, there is a formula. Okay, if you go further down, you can able to calculate each and every heat. Okay, so you can also go through this particular guideline. Okay, do you know as a HVAC engineer, we should know this equation, heat transfer equation, Q equal to MCP delta T, right?
Yes.
This is the sensible heat equation, okay, or you can say that the
Yeah. This
sensible
is
heat
in
transfer.
the. I think this equation we studied in thermodynamics.
Yeah, thermodynamics. So whatever we are doing air conditioning, it is a thermodynamics only. Okay,
Yes. Yeah.
okay, so that is the psychometric chart also is a part of the thermodynamics. ASHRAE guideline,
Yes.
the temperature study also part of the thermodynamics, right?
Yes.
Okay, so this equation you should understand Q equal to mCp delta T. M is nothing but mass of the material, Q is nothing but heat transfer, Cp is the specific heat, delta T is the temperature change. This particular equation is applicable for both water and air. Okay,
Yeah.
okay. When you talk about specific heat of water, specific heat of air, so you will apply that particular equations. Okay, and delta T is the
Yeah.
change in temperature of the material. It can be air or it can be water, right?
Yes. Yes.
So based on that, you can apply this equation for when you have a chilled water calculation, when you have a airflow calculation, you can use this one. Okay, this equation. Okay.
Yes. Yes.
Then if you
Yeah.
go further down, how to calculate the heat for the roof, there is a equation, same equation, Q equal to mCp delta T, the same equation but in different form. Okay.
Yeah.
And if you go further down, there is a wall load, window load. Okay, so there are different loads are there. I request you to go through this document, get some idea, then we will discuss further so that you will have a strong foundation. Okay, if I
Okay.
explain everything, then after some time you will forget.
Yes.
So I want you to go through
Yes.
so that
Yes.
you will get the knowledge, right?
Yeah, and one more thing, I have one. I drew. I have when I gone through the document, I just found this thermal resistance of particular. For
Materials.
example, yes,
Yeah, yeah.
yeah, and they have mentioned U value, and U value also we have studied about in the this thermodynamics only, like
Yes, yes, yes.
inversal of the resistance and all. If we
Yeah, yeah.
like for I just I have one doubt at that time. We are like mostly we are taking U values in the calculation for the glasses and all, but we have
No,
different
you
types of glasses, right?
yeah,
Like
you have
so
a
I
you have
don't.
a U value for wall, U value for floor, U value for the roof, U value for the glasses. Glasses, different
Yeah,
glasses having a different U values. Okay,
yes,
that we
yes.
will study. We will study. I will explain you how to calculate each and every U value. Okay, from where there is a guideline from the
Because
local.
last interview for the last interview they have asked me about U value, and where
Yes,
you
yes,
get
yes.
this, where from where you will get the U value for the different
Okay,
materials like that.
okay. If you want, let me go to one of the guideline. Okay, even the same page you can able to see here. Can you see that U factor for the different glasses? Single glazing,
Yeah.
double glazing, double glazing.
Oh, okay.
So this is the resistance. Based on the resistance, you will get the U value as well. Okay,
Okay, okay.
okay.
One by resistance or what? Same.
Yeah, yeah. It's a resistance. U, yeah. U is nothing but one by R, right?
Yeah.
Okay. So if you go further up, there is a calculation as well given here. Okay. Yeah. Can you see that the
Yes,
U
yes,
factor calculation? So each
yes,
and every material having a resistance. Okay.
yes, yes, yes,
The more the resistance, lesser the U value, right?
yes, yes. I think I
So
have done one before 1 year before. I just want to submit one document for this green building because
yeah, yeah.
we are as
But
we are a
but
civil contractor. I just want to the like for the plaster one U value, block one U value. We have like
yeah.
every item we have U value. We will take all the addition and we will submit for the total U
Okay.
value for the wall like that. I
Yeah.
just
That will
submitted
be by
before.
architectural engineer, right? Not as a mechanical engineer.
Yes, but in our before I just started as a contracting company. I have to do everything in that company.
Okay. Okay. Understood. Understood. That is very good. Yes. 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 Okay. So I
Yes.
request you to go through this particular whatever we said just now, ASTRE guideline, psychometric properties, type of understanding heat, sensible heat, latent heat, internal heat, external heat. Okay, start putting that foundation. Then it will really helpful for your next stage. Next stage when we discuss, it will really helpful. Okay, Tom.
Yeah. Sure.
Yeah. Thank you.